All right, let's talk about errors. You know that moment when your code just dies? It's probably the most frustrating part of programming, right? Well, we're about to flip that on its head. We're going to take that frustrating error message and turn it into your single most powerful tool. This is how you go from crashing to being in complete control. Let's get into it.
Oh yeah, we've all been there. You write some code, you're feeling good about it, you hit run, and boom, everything just stops. That sinking feeling in your stomach, what now? That's exactly what we're going to tackle today. So here's our game plan. First, we'll figure out what's happening when your code breaks. Then we'll talk about a huge mindset shift, seeing errors as your friends. After that, we'll get into the practical stuff, the programmer's safety net. Then we'll level up with some pro techniques. And finally, we'll tie it all together and see why this stuff is so important in the real world.
Okay, first things first. When your code breaks, before you can even think about fixing it, you have to know what you're dealing with. Because, and this is key, not all errors in Python are created equal. There are two main kinds.
And here's the fundamental difference. On one side, you've got syntax errors. The easiest way to think about these is like bad grammar. Python literally looks at your code and says, sorry, I don't understand this sentence. It can't even start. On the other side, you have runtime errors. Now with these, your grammar is perfect, but the logic is impossible. It's like asking someone to do something that just can't be done.
Let's look at a super simple example of a syntax error. See this? If 5 greater than 3, print hello. Now, you and I know what that's supposed to mean, but Python is super strict. It sees that missing colon after the 3 and just stops. The program doesn't even get a chance to run because the instructions themselves, the grammar, is broken.
Now, compare that to a runtime error. This code, print 10 divided by 0, is perfectly valid Python grammar. So the program starts up just fine, it understands the command. But when it actually tries to do the math, it hits a brick wall. You can't divide by 0 in math, and you can't do it here either. The program was running, and then it crashed. That's the difference. And that brings us to, honestly, the most important part of this whole thing. It's a mindset shift. I need you to stop thinking of errors as a sign of failure and start seeing them for what they really are. Your friends. They are here to help. So why are they your friends? I mean, they crash your program. Well, because they're not just a dead end. They're a report. An error message is literally telling you exactly what went wrong, and, this is the best part, where it went wrong. It's a guide that helps you fix things way faster than just guessing.
And this quote just nails it. A programmer who actually understands errors is 10 times better than one who just gets frustrated and ignores them. We're not talking about a small improvement here. This is a massive leap in your skill set. It's a total game changer. Okay, so if errors are our friendly guides, how do we actually listen to them without the whole program blowing up? Well, that brings us to the programmer's secret weapon, our safety net, the try except block.
The logic here is just so simple and so powerful. First, you tell Python, hey, I want you to try this piece of code. It might be a little risky. If it works out, great. The program just skips the next part and moves on. But if an error pops up, the program doesn't crash. Instead, it immediately jumps down to your backup plan, the except block, and runs that code instead.
And just look at the difference. Before, trying to divide by 0 meant a hard, ugly crash. But afterwards, once we wrap it in a try except block, what happens? The program keeps running. It just prints out a nice, friendly message that we wrote. See? You just took control back from the error. You're in charge now. Okay, you've got the basics of the safety net down. Now, let's level up. It's time to start handling errors like a pro. We're going to look at a few more advanced techniques. So a general except block is good. It catches everything. But a pro is more specific. You don't just want to know that something went wrong. You want to know what went wrong. So you catch specific errors, like except 0 division error. This lets you have different backup plans for different problems, which makes your code way smarter and a whole lot more robust. And we can get even more precise. You can add an else block. This is your success code. It only runs if the try block went off without a hitch. And then there's the finally block. Think of this as your cleanup crew. It runs no matter what, error or not. It's absolutely perfect for essential tasks like making sure a file you opened always gets closed. All right, let's tackle the thing that scares everybody at first, the traceback message. That big wall of text isn't angry shouting, okay? It's a detailed report. It's a map. As you can see here, it's telling you the whole story of the error, the exact line number where it happened, the specific type of error it was, and even a little description of the problem.
It's literally a treasure map pointing to the bug.
And now for the single best tip I can give you for reading these things. Do not start at the top. It's confusing. Go straight to the bottom. The very last line is your golden ticket. It tells you the exact error type and gives you the most important clue. Seriously, do this every time. It'll save you so much time and frustration.
So, we've covered a lot of the how, but let's step back for a second and talk about the why. Why does all this matter so much? Well, let's connect it to the real world. This isn't just some academic exercise. Error handling is the invisible backbone of literally all professional software. It's what keeps your banking app from failing mid-transaction. It's what stops your favorite video game from crashing to the desktop. It's the reason a website shows you a friendly oops message instead of just a broken white page. It is everywhere, and it's what makes software reliable.
So think about it. We started with that feeling of dread when a program crashes, and we've ended up here with the power to anticipate problems, to control what happens, and to keep our programs running smoothly even when things go wrong. That freedom from the fear of breaking things, is what lets you be creative. It lets you build bigger, better, more ambitious stuff. So the only real question left is, what are you going to build now?